network types in OSPF. First one is
Non-broadcast. So non-broadcast.
okay,
Then broadcast.
okay,
Point to multipoint. Point to multipoint non-broadcast. Point to point. Loopback and virtual link.
yes. So what is point to point network type?
Yes, sir. Point to point means interface on the so point to point we are using, right? One device connected to other device by the Ethernet cable.
Okay, anything else, guys?
And he
What
let
Point
us.
to
is
point, there is no DR-BDR election.
okay?
Yes, yes. Hello timer is 10 seconds and the data interval is 40 seconds. And next hop is not utilization on router. Next hop IP is not
Point to point
advertising.
means directly connection,
Yeah,
a direct
directly.
connection between two devices. It can be router, it can be PC, it can be to switch to firewall, right? Means whenever two devices are directly connected to each other, we can say that is
Point to point.
yes. Point to point means direct link or direct connection between two routers. By default, OSPF network type, our serial link is what?
Point
Uh,
to point, I think.
point to point.
Point to point, right? And where generally we are using serial link, guys?
When we don't want to advertise, selection in the DRBDR.
We are using serial link
Yes.
for the WAN, right?
Yeah,
For
valid.
the
Yes.
WAN connectivity. If we are going to connect our router to switch, even nowadays we are not using serial. Sometime we are using, but earlier we were using the serial link to connecting our edge devices to internet. Okay. So on the serial link or point to point WAN link, OSPF network type will be always at point to point. Second type of network is, and one more thing here I want to mention over here. Let's say if I will talk about OSPF network type point to point. So in point to point network type, OSPF router send hello message after every 10 second, and dead interval over point to point network type is 40 seconds.
40 seconds.
For time of hello.
For time of hello time.
DR and BDR not applicable. Not applicable. No DR and BDR required, because two routers are only exist. So even DR and BDR is not required, and by default routers will not perform DR and BDR election. Okay. And if I will talk about the neighborship, so both types of neighbor we can configure our point to point, the static neighborship or dynamic.
Dynamic.
Clear? We'll see these all point. Let me talk about second types of network, that is broadcast. So what is broadcast network?
Here DRBDR will be selection.
First of all, tell me about the broadcast network type. What is the meaning of broadcast? Broadcast means one to all. If I am saying
One
broadcast,
to all,
it means I
yes.
am talking about multi-access network. Multi-access network means where multiple routers or multiple devices are connected to common broadcast domain.
Single. Yeah.
Right, where we have multiple devices in the common broadcast domain. You all know the broadcast domain where broadcast message can be travel is known as broadcast domain. So whenever we have multiple devices means more than two devices, more than one, or generally we are saying more than 2,
2.
because between two devices we are using serial link or point to point link. If we have more than 2 devices, we are using broadcast network type. We will place switch there, right, and will connect all the devices through switch. So that type of network is called broadcast network or multi-access network. And in multi-access network, OSPF network type should be broadcast, right? In multi-access networks where multiple routers are connected to a common broadcast domain, like if I will talk about the example, so example can be Ethernet. In case of Ethernet link, where we are using Ethernet link for the LAN side only,
Yes, sir.
Yes, sir. Land side.
right? So in LAN side, what is happening is multiple devices are connected to switch, one router
Yes.
and maybe lots of N devices. So here you can see multiple devices are connected in through same broadcast domain. So network type should be what? Broadcast there. Clear? Hello interval, dead interval is going to be exactly same, and DR and BDR is required or not?
Yes, sir.
Yes, it's required, right? To avoid the LSA flooding.
Yes, sir.
So here DR and BDR election will, pen one daughter will become DR, one daughter will become BDR,
VDR.
right? Neighbor can be dynamically discovered over here as well. The
Yes, sir.
third type of network is non-broadcast.
Non-broadcast.
What is non-broadcast? Multi-access network that do not support broadcast, right? If I will talk about the example, so guys, there was an old technology called frame relay, ATM. You might have heard
Yes.
about frame relay and ATM, about these technologies. Hey, I'm getting noise, brother. Right? So again, I am talking about same multi-access network, but which not support
ATM.
broadcast, which
So this
not support,
technology is used nowadays.
huh?
Frame relay and ATM.
What?
This technology is used today. Frame relay and ATM.
See, sometime it's already implemented from the long time, but nowadays we are not implementing it, using it. Sometime you can find it, right, in the industry.
Okay.
Okay. And here hello time is going to be different. In which network type? In the non-broadcast network type, OSPF hello time is 30 second
30
and dead
second.
interval is
120.
120 second. And will DR and VDR election happen here? Is it required? Yes, still
Yes, sir.
required. If
Yes,
it
sir.
is
Yes.
multi-access network, then it's required, because routers
Because
are still sending multicast messages. Maybe
yes,
broadcast is
it
not supported, but multicast is supported.
support.
So DR is required here, and DR BDR election will happen here. But guys, dynamic neighborship is not possible in case of
Non-broadcast. Static. It will
in
use
case of non-broadcast network type.
non-broadcast.
Here we have to configure only a static neighborship,
Clip.
right? And remember the OSPF states there was attempt state. So you can
Yes,
see
sir.
that state over here only
Yes.
in non-broadcast network type. The fourth type of network is
And point to point, sir. Two-way. I think. Get
what?
stuck.
What to be? Dynamic
DR.
neighborship. Yes, we have configure also, right? In the lab, we have seen the
Okay.
OSPF behavior on serial link.
Okay. Okay.
Point to point, it will show us a full.
Point to point support dynamic neighborship. Broadcast also support dynamic
But there is
neighborship,
no there is no support. No, there is no diction in DR. That's why I am
but
saying
non-broadcast network type
network
does
type
not support dynamic neighborship.
membership. Yes.
Okay. Then we have next network type, that is point to
Multi-point, but
multi-point.
non-broadcast.
multi point. So what is point to multi point now? A single router is connected with multiple
Point.
routers. Right? A single point is connected with multiple point is called what? Point to multi point, yes or no? Like
Yes.
hub and spoke topology. In hub and spoke topology, we have one hub and multiple spokes, and all the spokes are connected to hub. All the spokes are connected to hub. Now tell me, is DR required there?
Yes, sir.
No.
No, 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 no.
DR is not
Not
required.
required.
DR and
Required.
BDR is not required because guys, all the hubs are connected to
Sir, can you make me understand by
all
the help of
the
diagram, sir?
spokes are connected to. Yes, we'll see that. Just give me
Because I
one
am not
overview.
not clear actually. That's to this.
We'll
I
see, brother, practical also.
okay. But sir, when you make my figure in my mind, then can you draw the link figure, so it will be very easy to understand me.
Point to point means I have
Point
one
to
router
multi.
here.
Okay.
So then point to multi-point means we have to configure as a static neighborship.
Dynamic neighborship is possible here. We can have
So point
dynamic
point to
neighborship in point to multi point.
okay, okay.
Point to multi point means I have router 1 connected to one switch and many other routers are connected. Right, so if I am saying this is my one router, hub router, and these are the spoke router S1, S2, S3 and S4. All the spokes will have, here only we have connectivity. Here only I have connectivity. Here only I have connectivity. WAN link, WAN circuit. Right here. There is no any WAN circuit between spoke 1 and spoke 2. Then we can say this is point to multi point.
Multi point.
Means one point is connected to multiple point.
Yes, yes, I got it.
Okay. So in point to multi point, again DR BDR required. Right. Generally we are using this network type in hub and spoke topology.
Non-broadcaster, how which type of scenario it will make?
Same
Point
scenario.
to
Same scenario. Same scenario. But here we have circuit between all the sites.
okay, DSL, DSL,
Here
DLI.
also we have connectivity. Here also we have connectivity. Here also. Here also. Here also. Here also. Like this.
DC का कुछ बनेगा, DC या DLC कुछ
Right. But guys, the technology which we are using here to connect all the sites together does not support broadcasting.
broadcast है.
Right. Frame relay is what? Frame relay is also used to connect multiple sites together, but it does not support broadcasting. Right, so there you have to configure a static neighborship only to avoid message on multicast address, because switch, let's say we have one switch, so if switch is not going to support broadcast, then it will also not forward multicast message. Switch behave both like same. Right, dynamic neighborship is possible here in case of point to multi point. Where we'll use this network type in hub and spoke topology. I'm expecting you know about hub and spoke topology at least. The next type of network is point to
Multi-point, multi-point and broadcast.
point to multi point non broadcast. Non broadcast.
Broadcast.
Point to multi point non broadcast. It is similar like point to multi-point, but again it cannot operate over broadcast. Point to multi-point which does not support broadcasting is called point to multi-point non-broadcast. It is same like point to multi-point but not broadcast, non-broadcast. So whenever you will see non-broadcast, that means dynamic neighborship is not possible here. Here we have to
Yes,
configure a
yes.
static neighborship
A
only,
static membership.
right? So it is similar like point to multi-point but operates in non-broadcast environment. We can say that, right? So again, if we have hub and spoke scenario, but the technology which we are using is frame relay, then you have to configure which network type?
Point to multi-point and broadcast.
Non-broadcast only, right? Nowadays you don't need to use non-broadcast network type or point to multi-point non-broadcast. Nowadays we are not using this network type, non-broadcast network type. The next type of network is, and one more thing here, again DR and BDR is required.
No,
Even if
no,
it is
sir.
required, because see, if you like broadcast message or multicast message are not allowed over here in this network, right? Then definitely DR BDR is not required because we are going to configure a static neighborship. Point to point is there,
Yes.
so DR and BDR is not required, and even DR and BDR election will not happen by default here in the non-broadcast network type also, and in point to multi-point non-broadcast network type also. And only we can configure manually the neighborship, OSPF neighborship, the static neighborship. The sixth type of network in OS network type is loopback. So loopback is a separate network type for loopback interface only. Loopback, where OSPF advertised prefixes with /32,
32.
right? So this is again logical interface that where we are running the OSPF, that is running a network, right? Virtual interface where we are running a network. Generally, why we are using loopback? The real use case of loopback is self-testing, right? And sometime for the router ID, that loopback IP address on the router will become router ID, and for self-testing. So you can say use case of loopback is router ID assignment or testing purpose. So if we are enabling OSPF on the loopback interface, always keep in mind network type is going to be only and only loopback only, and OSPF network type must be loopback also. Right? So router will always treat loopback interface as host. Router will always treat loopback interface, like OSPF will always treat loopback network type as host. Host means the particular IP address, correct guys? And no DR BDR election will performed over here. And the last type of network, last network type is
Virtual link.
virtual link. So you know we are using virtual link to extend which area?
Area 0 backbone area.
0. So again, the virtual link is a special type of network in OSPF, a special OSPF connection that extend OSPF connectivity across
Primary link.
like we can say a special connection which extend area 0 over regular area, over any regular area, which extend area 0 over any regular area. And on the virtual link, OSPF network type will be always virtual link. So virtual link is also one type of network in OSPF. Okay. And again on the virtual link, BDR election will not happen, right? No routers will become DR, and manual configurations are required for the virtual link. Manually you have to configure, like ABR router. ABR, a router whose one interface belongs to area 0 and one interface belongs to any regular area, that router will automatically become ABR router, right? But guys, there is no any scenario where virtual link will be automatically formed between the router. Here we need manual configuration. And to verify OSPF network type on the router, there is one command you already know. So IP OSPF interface and then interface ID, let's say F0/0. So this command is going to give you the detailed information of OSPF on fast Ethernet 0/0. Okay, you can also understand like this. Here we can create one table. Here we can say network type, then we can say hello interval, then we can say dead interval, then we can say DR and BDR, then we can say neighborship static or dynamic, and then you can answer in yes or no, like where DR and BDR election will happen, what will be the hello time on a particular network type. So this is just to memorize the concept, nothing else. That's why I'm just making this topology. Right. So here let's say I have which network type? Point to
Broadcast.
point.
Yes, point to point, sorry.
Right. Here we have, let's say, broadcast.
Yes.
Right. Here we have
Non-broadcast.
broadcast. Here I have point to multipoint. Multipoint, and here I have point to multipoint non-broadcast.
Non-broadcast.
Non-broadcast. Right. So what will be the hello interval over here?
So 10 second.
10 second. What will be dead interval over here?
40 second.
40 second. DR BDR. Not required.
Yes, right.
Not required. Not.
Static neighborship.
Yes.
No. Dynamic
Static
neighborship. Yes.
Yes.
In point to point, we'll have dynamic neighborship.
Okay.
Not a static neighbor. A static neighborship is not possible. We cannot configure even. Okay.
The DR and BDR, it's not required, but it can be, right? It can automatically.
No, it will be not there in the point to point network type. In broadcast network type only, a router will perform DR and BDR election. Okay. Here, what will be the hello interval? Again 10 second. Dead
10
interval
second.
40 second.
40
DR
second.
BDR. Yes.
Yes, sir.
Election will happen. Static neighborship.
Yes.
Yes, possible. Dynamic neighborship.
No.
In broadcast.
Yes.
Static neighborship
neighborship is yes. Static no. Yes.
No. And dynamic?
No. Dynamic yes.
Here 30 second.
Yes, sir.
120 second.
120 and 20 and 20. DRBDR yes.
DR BDR?
Yes.
Yes. Static neighborship?
Yes.
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 Dynamic neighborship?
No.
No.
Then in point to multi-point again. Hello time 30 second, 120 second.
DRBDR no.
DR BDR?
No.
No. Static neighborship? No.
Static neighborship no.
Dynamic neighborship?
Yes, sir. I think.
No.
Okay.
A static neighborship, where we have a static neighborship only in non-broadcast network type, right? Again here, in point to multi-point non-broadcast, timer is going to be same 30
second,
120.
Yes.
And DRBDR again in non-broadcast
no.
Static neighborship yes in the non-broadcast network type. and dynamic
No,
membership is
no.
not possible. So this way also you can memorize it. Clear?
Sir, in
Clear.
point to point, why there is no static neighborship happen?
In
Why it
point
cannot be happen?
in point to point network type, we have to configure dynamic neighborship only, right? That is this way only, like someone have designed the OSPF protocol. You need to remember these
Okay.
all things.
Okay. Then what about the broadcast? Is also same concept like P2P? Because I remember once you showed us an example of two router, and you showed how to configure static neighborship in between.
So maybe
Am I
that
right?
time network type is different, not point to point. Or
Until
brother,
now,
that was I
we
think the
learned
lab of
only.
EIGRP, not OSPF. In OSPF till now we didn't configure the static neighborship.
I guess in one video you showed us some, just for example.
I think no.
Mhm.
I didn't configure the
Okay.
static neighborship till now in
OSPF.
OSPF. Today I can try to
And is
configure a static neighborship here, our point to point network type, but I think it will not work.
sure, sir.
Okay.
Yes, sir.
So let's say I have two router R1 and R2. If the link between router 1 and router 2 is serial, then by default network type is going to be what?
Point to point.
By default network type is going to be point to point. And if you need DR and BDR here, what you can do? If you need DR and BDR between router
Then I
1 and
will
router
check
2,
network type. Then I
then
will
we
check
can
network
configure here
type.
network type what? We can change the OSPF network type.
Network type.
Right? What is the command? On the interface you will run IP OSPF network.
Network
And
type.
then whatever network you want to configure here. So here I can say broadcast,
Yes.
right? So always keep in
Broadcast
mind
and
the
broadcast
DR and BDR election doesn't depends on link. It
link.
depends on OSPF network type.
Network type.
This is an interview question that two routers are connected through Ethernet cable. Scenario number 1. In scenario number 2, two routers are directly connected through serial link. So in which scenario DR BDR election will happen, in which scenario DR and BDR election will not happen, and why? So in this case DR and BDR election will happen, in this case DR and BDR election will not happen. Reason, here by default OSPF network type is broadcast, here by default OSPF network type is point to point. Got it?
Sir, clear.
Right? Every time when you will connect two routers through Ethernet cable, it can be Ethernet, fast Ethernet, gig Ethernet, 1 gig, 10 gig, 40 gig, right? Every time you have to run this command. IP-OSPF network point to point on the port, on the link. Otherwise, OSPF process is going to be bit slow. Right? So we cannot leave it on default, by default. So when two routers are directly connected with each other, network type should be point to point only. When more than two routers are connected in the same broadcast network, then network type should be broadcast. Otherwise there will be LSA flooding. Right? So if I will talk
Sir,
about the WAN topology, yes.
sir, just for my knowledge, I would like to understand, is there any, for nowadays, fiber optic also available? Is there any specific network type for fiber optic?
So our fiber, how we are connecting, if you need to connect fiber optics on the router, on this router, how you are going to connect?
Using SFP, right?
I have this router, how I can
For-
connect fiber cable over here?
There is a fiber converter available.
SFP.
First of all, on
It's not.
on the router we have Ethernet port. Over the Ethernet port we are going to insert the SFP,
Ah, SFP, yes.
right? So your port is still what, Ethernet only, na?
Okay, okay, clear, clear. Okay.
Okay. So guys, if I will talk about the WAN topology. So in WAN we have generally two types of topology. Commonly we are using these two types of topology. One is full mesh topology, where my multiple sites are directly connected with each other. When you will have WAN circuit between all the WAN edge router, that particular type of topology is called full mesh topology. In EIGRP also we have seen full mesh and hub and spoke. Right? So in full mesh topology, my network type should be what? If I am saying full mesh, just give me 1 minute, guys. I have 3 sites. For an example, this is my topology. R1, side 1, side 2 and side 3. And all these sites are connected through service provider network. This way. If we have WAN connectivity between all the sites, means here also these two ports are able to communicate, these two ports are able to communicate, as well as these two ports are able to communicate. So this particular types of topology is called hub and spoke or full mesh?
Full mesh.
Full mesh, right? Where all the sites are connected to each other. All the sites are connected to each other. So this topology is called full mesh topology. But here, if I don't have connectivity between these two link, this port is not able to ping this port, then which type of topology it is? This is hub and spoke topology. All the spokes, then we can say S1, S2, spoke 1, spoke 2 and hub router. All the spokes are connected to hub. So in full mesh topology or in hub and spoke topology, OSPF network type will be different, right? For an example, this is my full mesh topology. Full mesh. So in full mesh topology, you can either configure OSPF network type broadcast or non-broadcast. Both types of network will work fine. The difference is in broadcast network type, you can configure dynamic neighborship. In non-broadcast network type, you have to configure static neighborship. But if I have hub and spoke topology, then my network type should be or can be spoke. Network type should be point to multipoint or point to multipoint non-broadcast. So you know where we should configure network type point to point between two routers. Where I should configure network type broadcast in multi-access network, means LAN side, and in WAN side either we can configure broadcast or non-broadcast if the topology type is full mesh, and we can configure point to multipoint and point to multipoint non-broadcast if the topology type is hub and spoke. What will happen if I will configure here point to multipoint network type, guys, in full mesh topology? there will be issue. Okay, in hub and spoke topology, if I will configure network type, let's say broadcast, then what will happen? Let's say this is my hub and spoke topology. Here I have connectivity, here I have connectivity, but here I don't have any connectivity. Here I don't have any connectivity. So can I configure OSPF network type, let's say broadcast here?
It's not possible.
What issue will occur if I will configure broadcast
W-
network type here?
w- One neighbor will be down, I think.
No. How,
Branch
brother?
1 and branch 2 start communicate.
Cannot communicate. Why they
From R
cannot
to
communicate?
R2 to R3, it cannot make a neighborship.
Branch 1 and branch 2 cannot become neighbor.
Yes.
Sure.
Yes, sir. There is no connectivity between this. So broadcast, it's not possible.
Router 2 will send their hello message on multicast address in the broadcast network, right? It will send to switch. Switch will receive out on this interface. It will forward to this interface. It will not forward from this interface because these two interfaces cannot communicate, right? These two interfaces cannot communicate. Even if there is neighborship, guys, between branch 1 and branch 2, then also there is problem. What will happen if this router will become DR? Now all the DR other have to send their LSA1 to DR router. Can router 2 send their LSA1 to router 3 to branch 2? No.
No.
It's not possible.
Right. So network type over here should be always what?
Point to multipoint.
Point to
Point to
multipoint.
either point to multipoint or point to multipoint non-broadcast.
Non-broadcast.
Okay. So you can see the implementation. Even on the switch you can stop communication between these two ports. How I can stop communication between these two ports? And I already told you one thing. Here see. Okay. Point to multipoint broadcast. Point to multipoint in hub and spoke, broadcast in full mesh. And if the technology is frame relay, any technology like frame relay which does not support broadcast technology, then only will configure what? Point to multipoint non-broadcast. In the Ethernet, we will always configure point to multipoint only, point to multipoint or broadcast. Okay. So if I will talk about the implementation, what we can do on switch, we can configure these two ports as protected. We can configure these two ports as protected. Let me check the configuration here on this router. So IP protocol. So no any routing protocol is running. So IP interface brief. IP is already configured in LAN side. You can see I have one loopback. On router number 2. So IP interface brief 20 and 192.168.10.2 fine. Then one more thing here we can verify. So IP protocol is not there. Okay. Then router 3 enable. So IP interface brief 10.1.3.1. okay, 10.3 and so IP protocol. Okay, so only IP configuration is there. If I am going to ping from router 1 to router 2, will ping work 192.168.110.2 router 2. Yes, ping will work. I am able to ping. Even I can ping router 3. Ping is working.
Yes.
From router number 2 also I can ping router 1 and router 3. Working and router 3. Ping is working. Now I want to stop communication between router 2 and router 3. On the switch we can configure these two ports as protected, right? So always keep in mind, in the switching you will learn it in detail about the switch port protected. Two protected port cannot communicate, but protected port can communicate with unprotected port. And by default all the ports on switch are configured as unprotected. So here I am going to say interface range E0/122 and switch port protected. So now these two ports cannot communicate. Now if you will try to ping router 3 from router 2, ping will not work. Now you can see ping is not working. And now I am going to enable OSPF. So router OSPF 1 router ID 2.2.2.2, then exit interface loopback 1 IP OSPF network. Here I am going to say point to point. On the loopback only I am changing network type, and then interface, sorry, let me enable OSPF also on the loopback interface. IP OSPF 1 area 0. Why I have changed the network type here? So that it should advertise this LAN prefix with /24. That's it. Then IP OSPF 1 area 0. Here I have enabled the OSPF. So IP OSPF interface brief. Okay. Then go to router 3 or router 1 and router interface loopback 1 IP OSPF network. Here also seeing point to point and IP OSPF 1 area 0. Exit interface F0/0 IP OSPF 1 area 0 and router OSPF 1 router ID 3.3.3.3. We'll have OSPF neighborship between router 2 and router 3, guys.
No.
Right. Now let me enable OSPF on R1. Router OSPF 1 and router ID 1.1.1. Exit interface loopback 1 IP OSPF network point to point and IP OSPF 1 area 0. Exit interface F0/0 and IP OSPF 1 area 0. So IP interface, so IP OSPF interface brief. So OSPF is enabled, waiting for DR and BDR, and so IP OSPF neighbor 3.3.3 is in two-way state and 3.3.3 is DR other, right? On router number 2, so IP OSPF, what happened here on router number 2? So IP OSPF interface brief. Okay, OSPF is not enabled on F0/0, interface F0/0 IP OSPF 1 area 0. So now we have neighborship. So IP OSPF neighbor. Who is neighbor? 1.1.1 and 1.1.1 is DR. So is there any problem here? Can branch 1 and branch 2 communicate, guys? R1 have neighborship with R2 as well as R3. There is no any issue. So IP OSPF neighbor on router number 1. Router 2 is DR other and router 3 is DR. This is the issue. 3.3.3 is DR. This is the issue. If I will make router 1 as DR router, then there is no issue. Then there is no issue. In this case, see, R3 is the DR router. So R1 and R3 are going to exchange their LSA1. R2 and R1 are going to exchange their database. Yes, we have full neighborship. So IP OSPF neighbor,
Yes.
we have full neighborship. Can R2 and R3 exchange database? No. So
R1
IP
only.
OSPF database. In database, you can see here, I have LSA1 of router 1, router 2 and router 3. That means router 2 is learning site 2 prefix, branch 2 prefix. Router 1 is learning branch 1 prefix and router 3. So IP OSPF database. All the LSA1 are there. Where is the issue? Are you able to see any issue here?
R3 become DR actually.
R3 became DR. Yes, R3 is DR. Router 1 is BDR. We can do one more thing here. We can enable, we can configure priority 0 so that these routers will not participate in DR and BDR election. Router 3 will be your DR only. No IP, sorry, IP OSPF priority 0. On router number 1, clear IP OSPF process. Router 3 has highest IP address, that's why router 3 is your DR. Now show IP OSPF neighbor. Now see, there is issue. Between router 1 and router 2 there is no neighborship. So now router 2 will not have LSA1 of router 3. Now router 1 will not have, router 2 will not have LSA1 of router 3. Soon it is going to remove this LSA. Clear IP OSPF process and show IP OSPF database. See, there is router LSA of router 2 only, right?
Yes.
Even I don't have router LSA of 1.1.1. So problem will occur when any spoke router will become DR. If I am going to make hub router as DR, if hub router is DR, then guys there will be no issue. Again, these two sides can communicate. Right, so on all the spoke router you have to configure priority what? 0. But again, this is not recommendation. In hub and spoke topology you should not configure broadcast network type because DR is there and always hub router will become DR. But really DR is required in this network? No, DR is not required. So to avoid the DR in hub and spoke topology, we have to change network type. We have to change network type. Even we cannot configure here point to point. Can I configure OSPF network type point to point, guys? No. There are multiple routers. Multiple spokes are connected to router number 1, to the hub router. So these two sides, branch 1 and branch 2, cannot communicate. Ping 30.1.1 and source 20.1.1. I think not 30, it's 10.1.3.1 and source 10.1.2.1. (20.1) on router number 3. So IP interface brief. So IP interface brief. Here IP is incorrect. Let me correct it. Config T interface loopback 1 and IP address 30.1.1 255.255.255.0. Right, so ping will definitely not work because route is not there. So IP route OSPF, here you can see I have only headquarter prefix, and on router number 2 in branch 1 even I don't have any prefix through OSPF. So IP route OSPF, there is nothing. Right. Now let me make router 1 as DR router. Here on router number 3 also I am going to configure priority 0, interface F0/0 IP OSPF priority 0, and on router number 1 I am going to remove this command, interface F0/0 IP OSPF priority 0, and I am going to say no to this command. Now router 1 will become DR and will have full neighborship with both the spokes. So IP OSPF neighbor, done, and both spokes are DR other. So all the spoke routers are going to share their LSA1 to their neighbor, to hub router, and hub router is going to share their LSA1 to all the spoke routers, because hub have neighborship with all spokes. So in this case, what is the issue? Is there any issue, guys? So IP OSPF database. See, all the LSAs are there on router number 2. On router number 1, all LSA1 are there, that is fine. On router number 2 also, all the LSAs are there. So IP OSPF database. All the LSAs are there. And let me show you the routing table. So IP route OSPF. 30 subnet is there. 30
Yes, sir.
is there. But what is the next hop IP address?
3.
Can I ping
There
this
no.
IP address?
Where 3?
Can I ping this IP
Not possible.
address? Not possible. So
No.
can
Not
I ping
possible.
30 subnet?
30 subnets.
Can I ping it? No.
No.
Right?
Yes.
So still if we have route also, then also we can not send the traffic. Right? So better to change what? Network type here. See, in all the possible ways we tried, but sites are not able to communicate, and still there is DR. Even DR and VDR is not required. On the hub router, we can do one more thing to make communication possible. Interface F0/0 IP next hop self. This is for EIGRP.
It is applicable for EIGRP, I think. There is no this kinds of command run in the OSPF.
OSPF, right? Because in the OSPF, routers are not going to exchange the route, right? So it
Yes.
will not modify the next hop. Router is sending the LSA. So the next hop command is not available here, right? So guys, there is only one solution, that is changing OSPF network type. Here you can see in hub and spoke topology, broadcast network type is not working. Even non-broadcast network type will also not work. If I will try to configure non-broadcast network type, let me say, see, interface F0/0 IP OSPF network non-broadcast, and let me copy this command. I'm going to put it on all the routers. OSPF never goes down because the network type is mismatch. Soon network type is going to match. Interface F0/0 IP OSPF network broadcast, and on router number 3 also network non-broadcast. Now we don't need to configure priority 0 and those things. Now DR and VDR election will not happened here. But guys, will neighborship come up? Tell me, will neighborship come up here? So IP OSPF neighbor, no. Because in non-broadcast
No,
network type we
static.
have to configure
Static.
a static neighborship. Dynamic neighborship is not possible. So let's configure a static neighborship here. Go to router 1, config T, say router OSPF 1 and neighbor. Who is neighbor? IP address of neighbor 192.168.10.2.
10.2, yes.
That's it. Then go to router 2 and router OSPF 1 neighbor 192.168.10.1. Now I am expecting OSPF neighborship between R1 and R2. Neighborship is in which state? Attempt state. Similar like
Init state, like
init state. Yes. On which interface? On fast Ethernet 0/0. IP address of neighbor is this one. Okay. Soon the neighborship will come up, but guys, the convergence OSPF speed is slow over here in a static neighborship. So wait for some time. Till then, let me configure the another neighbor also. On router number 1, I can add one more neighbor command, 192.168.10.3, and on router number 3, config T, router OSPF 1, and neighbor 192.168.10.1. Now router 1 have now neighborship with both the router, so IP OSPF neighbor, and this time you can see DR other on router number 2 also, so IP OSPF neighbor, so IP OSPF neighbor. Here is the DR. How it's possible in the non-broadcast? How DR router can be there, guys? On router number 1, let me verify the network type. Yes.
yes, sir. This is confusing because when we look at the table,
and so IP OSPF interface F0/0 include network non-broadcast. In non-broadcast network type, how DR router is there? So IP OSPF interface F0/0. What I said? In non-broadcast DR router is,
yes, it's clear. Yes, correct. You are correct.
sorry, I was thinking about the static neighborship. Okay.
Because there is today too much information, that's why it's confusing. Static neighborship, DR, BDR, mixing up much information.
Correct. I was also thinking about the neighborship, only static neighbor.
So it is very hectic to
dynamic
remember.
neighborship is not there, na? DR will be there.
Yes. First we have to cram on all neighborship, then
Again,
it
we
will
have
be.
same issue here. The DR router is there, and apart from that, so IP OSPF database, in the database LSAs are there, but the next hop is not
Yeah.
reachable.
Yeah,
So
correct.
IP
Yes,
route
next stop not
OSPF.
away.
Now can I try point to multi-point here, network type?
Yeah, multi-point is better option.
That will work fine. That will work fine here. On router number 1, config T, interface F0/0, IP OSPF network, point to multi-point. Okay, and so IP OSPF neighbor. Now there is no DR, no BDR. Good. Spoke routers, and all on the spoke routers also you can configure point to multi-point, interface F0/0, IP OSPF network, point to multi-point. Can copy the command and let me put it on router 2 as well. Neighborship is already there, by the way. Right, if network type is mismatching, then sometime database will be not synchronized, not exchanged. And now you will see everything is working fine. So IP OSPF neighbor. So who is neighbor? Only a spoke router, but there is no DR and BDR. And so IP OSPF database. All the LSAs are there. And so IP route OSPF. Next of IP address is hub router IP address. Sorry, for 30 subnet here. Next of IP address is on router number 2 on in branch 1 you can see now 30 subnet is coming from where, guys?
From headquarters.
From the hub router, right? So via hub router now both the spokes or branches can communicate.
Sir, I have a question here. So on this scenario, static neighborship is not possible.
No. In broadcast network type, a static neighborship is not possible. You can try to
So,
configure that between two router by connecting two router here, and you can try to configure a static neighborship to check it's working or not. We can check that in GNS3. Parallelly, I am opening GNS3 also. It will take some time. Till then, let's understand here only. Okay. So see, point to multi-point network type is working fine. One more types of network is there that will work fine here. Which is, guys?
sir,
Point to multi-point
here I
non-broadcast.
have one small, yes, sir.
But if network type is point to multi-point non-broadcast, then you have to configure a static neighborship.
Sir, here I have one question. Sorry.
Yeah, go ahead.
Yeah, generally this one, if you configure on the WAN side means R2 and R3, it will have access, right? Because this is WAN internet connection.
So you are going to purchase the WAN connectivity, na brother, from the ISP. For each circuit you are paying to ISP. So here I am not paying. Here I am paying only. For this connection I am paying. For this connection I am paying. I am not paying anything for this connection between a spoke. Let's say I have one side in Delhi,
Okay.
which is connected to ISP, right? They provide me the public IP address and I am paying for that public IP address.
Okay.
Then another side, spoke 1 somewhere. Here again I have one public IP address and I am paying for that. Now between Delhi and this side I can configure what? VPN, virtual private network. To create VPN over here we need a static IP address and we have to pay to the ISP for this WAN connectivity. In the same way, when I will add the new site here, we'll pay for this circuit also. If you want connectivity, if you want to form VPN over here also, then also you have to pay for this circuit. This is called WAN circuit.
I thought each router it has a public IP address so that it spoke both it will communicate.
Not like that. Here we are talking about WAN circuit, that here we have, or if the all routers are directly connected with each other, then here these two ports can communicate, these two ports can communicate, but these two ports can not communicate. Think like that. Right? So disadvantage of hub and spoke topology is all the communication is going to be possible
Through head.
Via head. So
Only headquarters.
Load on headquarter can be high. Right? A speed can be, guys, there should be latency also. There will be latency also when branch 1 and branch 2 are going to communicate, because first traffic will route to headquarter, then headquarter will route traffic towards other side. Right? So if cost is not your priority, then you can purchase link over here as well between branch 1 and branch 2. If redundancy is your priority, your speed is your priority, then you will have connectivity WAN circuit between all the sites. That is full mesh topology, right? If I will remove switch configuration, switch port protected configuration from the switch, then my topology will become what? Full mesh.
Full mesh, yes.
Right? And the network type? should be broadcast or non-broadcast. So there was one question that can we configure a static neighborship here in broadcast network type. Is it visible, guys? Console is visible?
Yes,
The
sir.
new
Visible.
console. Interface F0/0 no set IP address 12.1.1.255.255.255.0 exit router OSPF 1 router ID 1.1.1 and neighbor 12.1.2 router 2 config T interface F0/0 no set and IP address 12.1.2.255.255.255.0 exit router OSPF 1 route ID 2.2.2.2 and neighbor 12.1.1. So IP OSPF neighbor. So IP OSPF interface brief. Let me enable OSPF on the interface also. So but if I will enable OSPF on the interface, it will start sending dynamic. It will start discovering the neighbor dynamically. IP OSPF 1 area 0. What it's saying? A static neighborship is
Yes, sir. It's incompatible
incompatible,
with the net Ethernet
not compatible with which network type?
network type. It's
It's saying
broadcast.
fast Ethernet, means it is talking about broadcast network type.
Broad.
Right
So on the
here also
broadcast
you can
static not
see
possible.
NBMA, non-broadcast multi-access network, and point to multi-point network. Right? So not possible, brother. Someone was saying we had seen the static neighborship configuration between two router. So no, brother, that was EIGRP lab.
So my understanding, static neighborship is only possible on non-broadcast network type. Remaining all
Yes,
dynamic neighborship, it's possible.
dynamic neighborship. Yes,
Oh, okay, sir. Okay.
in non-broadcast, right?
Yeah,
Non-broadcast
non-broadcast.
or
Yes.
point to multi-point non-broadcast. Okay. In these two cases, we'll configure static neighborship. Okay. So let's come on this topology again. Can I close it? Delete it? Okay. If there will be anything, then we can use that. I'm not closing it for now. Okay, so guys, here you can check connectivity 30.1.1 and source. I can check from router 3. Ping 20.101, source 30.101. Ping is working. Even you can check trace route 20.101, source 30.101, numeric. Okay, so traffic is going via headquarter. Broadcast network type is working fine here. Doesn't matter which router is DR. If spoke router is DR, then also it will work because all the sites are directly connected with each other, right? As well as non-broadcast network type will also work fine here in this scenario. You can try to configure non-broadcast network type also. Config T.
Sir, what we are going to configure? Point to non-broadcast.
This is full mesh topology. Here network type is broadcast and everything is working fine.
Yeah.
So what I am saying here, either you can configure point to point or broadcast or non-broadcast. That's it.
I'm sorry. This topology currently it has point to multipoint, right?
Network type is point to multipoint here.
Yes.
So
We
till
have
now I
configured
have
as-
not configured full mesh topology. This is hub and spoke topology. What I am saying, if I will remove this command, protected command, interface
Okay.
range E0/1 to 2, then if I will say no switch port protected, after that network type should be
Full mesh.
broadcast. Yes, the network type should be broadcast or non-broadcast. If this is hub and spoke topology, you have seen the point to multipoint and point to multipoint non-broadcast. Both network types are working fine, but broadcast and non-broadcast network type was not working. Correct? In the same way, here in full mesh topology, broadcast network type and non-broadcast network type will work fine, but rest type of network type will not work fine. See here now. This is my full mesh topology. Again I am able to ping. What is happening here? Ping. Okay. Router 4. So IP OSPF neighbor. Guys, is there any DR?
There is no DR.
Right? Is DR required? Yes. Yes, DR is required because multiple routers are connected with same broadcast network. All the routers are connected with each other. Otherwise, LSA flooding will be there. Yes or no?
Yes, sir. Yes, correct. Yes.
So we should change
Lots
the
of
network
unnecessary
type
trouble.
here. So we have to change the network type. Clear?
Sir,
IP
for my
OSPF.
for my confirmation, currently what the network type it is?
Point to multipoint non-broadcast. Or side, I
Point
think
to
point to multipoint. So
Yeah, that is what.
IP
Yeah, confirm please, sir.
So IP OSPF interface F0/0. Either it is point to multipoint or point to multipoint non-broadcast. It is point to multipoint.
Point to multipoint. Yes.
Right. So in point to multipoint, we don't have DR.
DR,
But
DR.
guys, in this case, DR is required. Right. So what network type I can configure here? Either I can configure broadcast or non-broadcast. In these two network types only I have DR. Yes or no?
Yes, sir. Correct.
Okay. So that's all for
Sir, by the
network
WAN
type.
link,
Mhm.
generally company side, which one they are using for broadcast or non-broadcast for the WAN side? Through WAN.
WAN side, it depends on your topology type. How you have designed, how you have connected the sites, all the sites together. If it is hub and spoke topology, then network type should be point to multipoint. And not only hub side or a spoke side, network type should be same both side. Network type should be same. Okay. And in full mesh topology, network type should be broadcast or non-broadcast. So what you need to keep in mind, this thing, these two things, that in hub and spoke topology, either I can configure point to multipoint or point to multipoint non-broadcast. In full mesh topology, I can configure broadcast or non-broadcast. Between the two routers, I will configure point to point. And there are two more network types in OSPF. One is loopback, one is virtual link. So you already know.
Sir, here the class is too much information and too much thinking. This is much confusing, really. I have to go through it, this class again. Video.
Like nothing is confusing. You can see the issues are in front of you only, na brother. When first what
Yes,
we
yes,
did,
yes.
first we create hub and spoke topology. After that we try to implement broadcast network type there, but there was issue,
Yes, yes.
right? Then we configure non-broadcast. Again there was issue. The LSA was extended, but the next hop issue was
Yeah.
there between the sites.
Both spoke was, yeah, both spoke not communicate.
Correct. Right. Then we change network type to point to multi-point. Then everything
Point to
start working
multipoint, yes.
fine.
Yeah.
Right. And now I have created full mesh topology.
Full
And in
mesh
the full mesh
topology. So,
topology, if my network type is point to multi-point, then there is no DR and VDR. So I have to configure broadcast here, either broadcast or non-broadcast. Again, if it is
non-broadcast, yes,
broadcast,
correct.
then neighborship will be dynamic in nature. If the network type is non-broadcast, then manually we have to configure
Then
the
on be
neighborship.
static.
Yes,
Static.
static neighborship.
But information is too much today. Too high.
Karthik, yeah, tomorrow is
Yeah.
Saturday, then
Sir, you
Sunday.
are you have much experience. So you are, but for us, it's first day class is difficult
See,
today.
these are the theoretical part, right?
Mm-hmm.
I know because I have implemented, after I have implementing, when I am implementing the scenario in the topology, right? So then only I am also recalling the concept. Okay, if you will ask everything to me, then maybe I can also not answer directly. So try to imagine the topology, try to implement the OSPF there and network type there, and then try to think what will be the issue there, right? Or just go through
Correct.
this table for next few days. Just see this table for 2 to 3 days in the morning. I just think why I'm using point to point between router, why I'm using broadcast in multi-access, non-broadcast, point to point, and point to multi-point non-broadcast. That's it.
Yes, sir. This one we have to image. Yes, correct.
Right. Now the next concept that we can understand here is virtual link. In this case, guys, you can configure, implement broadcast and non-broadcast, then the topology will work fine. Topology will work fine. The OSPF will work fine. Right. For now, let me open another topology for virtual link. Virtual link, where we can implement virtual link. Here it is. And this topology we can implement virtual link. Where virtual link is required? Between which router?
Area 2.
Between
Area 2 and 0.
which router is ABR, guys?
R2 is
R2
ABR.
is ABR.
R2 is the ABR. So we need to create virtual link from R2 to which router?
R4.
To
R4.
R4.
Right. Now make sure there is reachability between R2 and R4 first before implementing or configuring the virtual link. See, let me check OSPF is enabled or not. First of all, here, if somehow OSPF is enabled, then great. So IP protocol. Okay, great. OSPF is already enabled. Right. So IP OSPF interface brief, done. And so IP OSPF neighbor, what happened? I think OSPF is then not enabled on router number 2. Yeah, router 2 is fresh router. Let me configure it very quickly. Router ID is 1.1.1. Okay. Enable config T and do so. IP interface brief IP is also not there, so interface f1/0 no set IP address 12.1.2.255.255.255.0 and do ping 12.1.1. Okay. IP OSPF1 area 0 and router OSPF1 router ID 2.2.2.2. Can I change the router ID now? No. Do clear IP OSPF process. Say yes, and after that change the router ID quickly. So IP OSPF neighbor two-way. Okay. Till then, let me configure which interface f2/0 interface f2/0 IP address. Here I am going to go to 23.1.2.255.255.255.0. Say no set and IP OSPF1 area 1. Okay. So IP OSPF interface brief done. Let me take you to R3. R3 is also new router. R4 is also new router, and R5 is also new router. Let me save the configuration of R2 first. Okay, and on R2 there is one LAN interface also, that also I can configure in area 0. IP address 20.1.1 255.255.255.0 and IP OSPF1 area 0. One more thing you can do between router 1 and router 2, you can configure OSPF network type point to point. So whenever you are practicing OSPF, guys, must configure network type point to point between the routers. Okay.
Two routers.
Yes, between two routers. Config T, then interface f1/0 no cert IP address 23.1.3 255.255.255.0 IP OSPF 1 area 1. Exit. First I should configure router ID, but nobody. Interface f0/0 no set and IP address 30.1.1 255.255.255.0 IP OSPF1 area 0. Exit. Interface f2/0 no set and IP address 34.1.3 255.255.255.0 IP OSPF1 area 1. Okay, so R3 will be receiving all the LAN subnet from area 0 because ABR router is connected with this area. So IP OSPF border router 2.2.2 is border router, right? So border router is advertising LSA 3. Yes, na? 10 subnet and 20 subnet is coming in form of LSA 3 only.
LSA 3, yes.
Right? Okay. Now here router ID should be 3.3.3 for better understanding. Router OSPF 1 and router ID 3.3.3.3. Do clear IP OSPF process. Yes, and router ID 3.3.3. Let me take you to router 4 now. And on router number 4, till router 4 will not have any issue, right? Till router 4 I will have all the prefixes. Interface, and before configuring interface router OSPF 1 router ID 4.4.4.4. exit interface F0/0
F1.
no set
Sir, F1/0.
interface F1/0 no set and IP address 34.1.4.255.255.255.0 and IP OSPF1 area 1. And here I have
1.
one interface in area 2. Interface F2/0 no set IP address 45.1.1.4 255.255.255.0 IP
0.
OSPF1 area
2.
2. Right, so this router will not become ABR router, and that's why we'll have issue on router number 5. Config tree interface F1/0 no set IP address 45.1.5 255.255.255.0 IP OSPF1 area 0 exit interface F0/0 no set IP address 50.1.1 255.255.255.0 and IP OSPF1 area 0 exit router OSPF 1 and router ID I am saying 5.5.5. Clear? So IP OSPF neighbor. Why we don't have OSPF neighborship here, guys?
There is no backbone area connectivity.
It cannot
No,
reach
so
the
between router 4
backbone.
and router 5 we should have neighborship, na?
Oh.
Here we should have neighborship.
Yeah. I think when you're configuring, you made it, one of the
Yes, here I
interfaces you
am
made it
getting
clear
log
as
message
0
as well.
on R5. Can you please check? Yeah.
Yes, here I am getting log message as well. So IP OSPF interface brief. So one is F1/0 is in area 1 and F2/0 is in area 2 on router number 5. So IP
Area mismatch.
OSPF interface brief. Here I have configure both interfaces in area 0. So interface F1/0 1/0 IP OSPF 1 area 2. Now so IP OSPF neighbor. Now we have neighborship, right? And so IP route OSPF, you can see I am not receiving any route through OSPF routing protocol, right? So IP OSPF database, I don't have any router LSA of area 0 or area 1. I don't have
Yes.
router LSA of router 3, router 2, router 1 here. There are 2 router in area 0, so there are only 2 number of LSA, router LSA. Fine. So here guys, let's do one thing. Let's create virtual link between router 2 and router 4.
4.
Configuration is going to be very easy. See what I am going to tell to router number 2. On router number 1, again I will be not receiving this 50 subnet. On router number 1, you can check the routing table. Run command like this. So IP route and 50.1.1.0. Network is not in table. And on router 5, so IP route 10.1.1.0. Network is not in table. Right. So let's configure the virtual link now. Configuration is very simple. Router OSPF 1. And what I will say? Which area? Area 1. See, area is going to be that area over which you are creating the virtual link. So over area 1 I am creating the virtual link, right? So first of all I have mentioned the area over which area I am creating virtual link. So over area 1, and after that virtual
Yes.
link, then router ID of router,
R4.
router ID of neighbor router R4. Yes, 4.4.4.4. 4.4.4.4. Now 4.4.4 is reachable from router number 2. Router 4, yes, it is reachable. Same command we need to run on router number 4 also. Go to router number 4 and here say router OSPF 1 and again area 1 and the virtual link, router ID of router 2.2.2. Now we'll have neighborship here, you can see, right? OSPF VL0, virtual link 0. So IP OSPF neighbor, right? So see this neighbor. Interface over here is this one, virtual interface, right? And now so IP, I am on router 4. Here I am running so IP protocol command to check this router is behaving like ABR or not. So guys, this router is now behaving like ABR router. So now R4 became ABR. R4 is going to generate
ABR.
LSA3 to advertise 50 subnet in which area? Area 0. In area 1
Area
first
0.
and then area 1 to area 0. Right, router 2 can forward that the LSA3 to router number 1. So now on router number 1, if you will check 50 subnet in the table, still 50 subnet is not available in the table. What happened? We'll troubleshoot it. On router number 5, 10 subnet is now in table. 10 subnet is there in the routing table of router 5, but why 50 subnet is not there in the routing table of router 1? Let me check first R4 routing table. So IP. Even here also we don't have 50 subnet.
Yeah, I'll check the interface brief. Do show IP OSPF.
Area ID is still incorrect here.
0, yeah.
Interface F0/0 IP OSPF1 area 2. Right, and then go to router 1 and then this command. Wait for some time. Now you can see prefix is in table and ping 50.1.1 source 10.1.1. Ping should work. Why ping is not working?
R12.
Now we need to troubleshoot the issue. What happened here? Trace route 50.1.1 source 10.1.1. Traffic is going to router 2, then router 3, and after that router 3 is not able to forward it to router 4. Go to router number 3 and see so IP route 50.1.0. 50 subnet is not there in the routing table of router
Router 3.
3. So IP OSPF border router here 2.2.4.4.4 is ABR router, 2.2.2 is also ABR router. So IP OSPF database. In the database, let me check summary LSA for 50 subnet. Yes, router 4 is advertising 50 subnet. Right? Here it is. Let me open it in detail. Summary and 50.1.1.0. Matrix 2, okay. See guys, what is the issue? What is the issue here? interface loopback 1 IP address 4.4.4.4 4.4.4.4 255.255.255 IP OSPF 1 area, let's say 1. Right, so next hop was what? 4.4.4, which was not the IP address earlier. What was happening? Next hop was there 4.4.4 advertising router ID. So IP OSPF database summary and this one. See what informations are there. Link state ID 50.1.1.0 and the advertising router ID 4.4.4. So
where is the next hop IP?
next hop is so IP route 50.1.1.0. Here it is.
4.4.
So router 3 is saying that okay, I am receiving 50 prefixes from 4.4.4, but router 3 don't know how to reach 4.4.4. Router 3 don't know how to reach 4.4.4. Are to know how to reach 4.4.4 because guys there is one direct virtual link between router 1
Virtual
and
link.
router 4.
Sir, for our understanding, but R3 and R4 both are in same area 1. So
Right?
it
Both are
has to
in
understand,
same.
right? Yeah.
No, 4.4.4 is not IP address, no brother. That was the router ID. So see, if you are receiving some prefixes from your neighbor and with the router ID, which is not routable, then you cannot install
Okay.
that in the routing table because that IP address is not routable. Now I became 4.4.4 as reachable from router number 3. Then router 3 have installed the prefixes in routing table.
So in this case, redistribution required.
Not redistribution, nothing is required. Now you can check the connectivity.
But router 3 and router 4 are physically connected, so and it are in same area then.
Yeah. This is my question. Yes.
Sorry, what is the question?
Router
Router
and yeah.
router 3 and router 4 are physically connected via 0/2 and f 1/0, right? And both are in the same area. Then why router 3 are don't know how to reach that R4?
No, router 3 know how to reach the R4, but router 3 don't know there is one ABR 4.4.4.4. How to reach this 4.4.4, that is unknown for router number 3. How to reach, not you can say router number 4, how to reach the ABR is unknown.
ABR. Okay.
Right, this is new ABR whose router ID is 4.4.4 and how to reach that ABR is unknown. Because guys, see now router 4 is connected in area 0 also, in area 1 also, in area 2 also. In all the area is going to generate their LSA 1. But area 0 LSA 1 will be not advertised in area 1, right? So there will be no LSA 1 of area 0 in the database of router 3. There will be LSA 1 of router 4 of area 1 only. Getting my point? This router is connected with now 3 areas. Area 0, area 1 and area 2. In all the areas it is going to generate LSA 1. And between the area it is generating what? ABR router is generating what? LSA 3. How this router will get to know about this ABR? Router 2 is my ABR and how to reach this ABR? This router is going to on which bit? B bit.
B bit, yes.
Right? But guys, router 4 is going to on their B bit in which LSA? In the LSA which it is advertising through the virtual link only.
Area 0.
Not only the virtual link, even it will on B bit in their all LSA 1 in all the area. Then only this router will get to know about ABR that 4.4.4 is my ABR. But when this ABR was advertising LSA 3, the next hop IP address was not routable. Next hop IP address was not routable earlier, and now the next hop IP address is routable because router 4 is generating LSA 3 with their router ID 4.4.4, which is not routable until and unless you have not configured that IP address on the router number 4. So that's why here I have created the loopback. Okay, if there is only one area, and here let's talk about this 40 subnet. So the 40 subnet you don't need to advertise 4.4.4 in OSPF, but for this 50 subnet you have to advertise it. And guys, how router is going to send hello message on virtual link? Multicast or unicast?
Multicast.
Not multicast, unicast, right? And both the routers are going to on one more bit here. Which bit? V bit.
L bit.
V.
Okay, okay, okay.
Right? We talked about B bit, E bit, and V bit. So router will on V bit in the LSA 1 over the virtual link. V bit represent what? I am the virtual link. That's it. I am the virtual link.
So, sir, we have created the loopback address 4.4.4.4 in R4 because of R3 has to reach this ABR. That's why we have created this loopback to
Yes.
avoid this problem.
Yes. So what is happening here? Whatever LSA 3 router 4 will advertise in this area to router number 3, right, in area 1 from area number 2.
Here 2.
Every time there will be two information, link ID and advertising router ID. Link ID will be the subnet and advertising router ID will be 4.4.4.4. But these router don't know how to reach 4.4.4. So that's why I have advertised it. Now router 3 know to reach 4.4.4. This will be the IP address, next hop IP address, right? So same IP address will become next hop for all the prefixes which are coming from area 2 to area 1.
But router 3 already know this 4.4.4 as a LSA 1, router LSA as a, right? In same area 1.
Yes, in area 1 it is knowing that. In area 1, router 4 is known.
But for the summary
When
LSA, it doesn't
we
know.
have configured the virtual link, then only we need to advertise that. Then there was issue.
Understood.
There is some more concept of virtual link, but that you don't need to learn now. Like regarding the security, sometimes you need to run some extra commands in real time if we are creating the virtual. By the way guys, in real time nowadays we are not using the virtual link concept, because every time our backbone network will be in area 0, which will be connected to regular area like this, right? So virtual link is not required, but in case if virtual link is required in 2% case, then you have to secure this. This is not secure. TTL value in the hello message is going to be 255. So it can reach to up to 255 routers. So to limit this TTL value, we need to run one more command like area 1, then virtual link 4.4.4.4, and then we can say TTL security and whatever value you want to define. You know TTL value should be 3 here only. So you can configure 3. Then you can configure authentication for the virtual link. Area 1 virtual link 4.4.4 and authentication key. We can define the key. Let's say Cisco 123. So those are some security feature over virtual link. Then virtual link works on DND. Like as I told you here, it will send unicast hello message. Unicast hello message. So hello message will be also exchanged only once. After becoming neighborship, it will not exchange hello message over virtual link. DND means, what is the full form of DNA? Sorry, not DND, it's DNA. Do not edge. Do not edge. DNA is an concept over virtual link. Do not edge. So like you can see on daughter number 4, if I will show you show IP OSPF, show IP OSPF neighbor. So guys, date time is running for all the neighbor except this neighbor. There is no any timer, date timer for this neighbor. So this neighbor is not going to dead.
Okay.
Okay. So and not any timer, age timer is running for neighbor found on virtual link. Okay, so that is the meaning of DNA. Do not age.
Sir,
So
is it possible to ping the router ID from one router to another router?
no, not possible. No, that's why here I have created the loopback. If it is possible to ping, then we don't need to advertise and we need to create the loopback here.
Because router ID is also unique, it's 32-bit
But that is not the IP address. That is not routable, na. No one is running. Nowhere is that is running, right? That IP address. That is just an identity of database.
Identity, okay.
Right. So over the virtual link, router will on DNA bit. DNA is also one bit in the LSA1. Right. So by default, all the routers send LSA1 with DNA bits off, but over the virtual link router send LSA1 with DNA bit on. Like run as demand circuit. Do you know run as demand circuit? What is the meaning of demand circuit? Run as demand circuit. If anyone have idea about this, they can correlate and understand this. Right? If you don't know, no worry. Run as demand circuit. Even on the serial link, in this case, in this scenario, you can configure DNA. We can say interface serial 2/0 and then IP OSPF what? Demand circuit. Right? After running this command, you will see the age time is nothing on that interface. It will stop using age for the particular neighbor. There is no any timer running for that neighbor now. So you can do this lab. Okay, just take one screenshot of it and after the class you can try it.
Sir, please IP OSPF demand circuit, please one more time explain so that we will try lab.
See here, I don't want that router 1 should run any timer for this particular neighbor to R2. Then I can use what I told you, DNA. Do not age.
Okay.
Right, so stop the date timer for the particular neighbor. Like if router is not going to receive any hello message for 40 seconds, then it will declare their neighbor as dead. Yes or no? But we don't that.
Yes.
Then we can use this interface as demand circuit.
So IP OSPF.
This is one very advanced concept of CCI. Really, you don't need to learn here now. Okay, just learn these all the concept: network types, area concept, and OSPF LSAs, states. Those are messages. Those are the input. These are the important things for you. Now, guys, in OSPF, what remaining topics are there? See, we have covered all the topics of OSPF, which is a part of your CCNP syllabus, CCNP NRC, right? The remaining topics are distribute list. Yes, go ahead.
Serial link, sir. Serial link we have not configured. How to
Okay,
configure the serial link?
configuration is same here, the serial link also.
Because I didn't have experience on serial, only Ethernet.
So you can connect serial link over here, nothing is different, both are same. Serial 3/0, serial 3/0. In lab 1 I had connected serial link only, brother, in OSPF. Okay, so R1, R2, interface serial 3/0, no cert, IP address 30.1.1.255.255.255.0, IP OSPF1 area 0. By default network type over here is point to point only. So
Point to
IP
point.
OSPF, interface brief. So this way only we are configuring OSPF1 serial link also on router number 2.
Sir, but somewhere I read there is I forget there is a DTE DCE somewhere configuration required on the serial.
I don't have idea about that, but that is not required here. Soon neighborship will come up. 30.1.1.2, 30 subnet only I have configured on router number 1, right, Ajay? And IP OSPF1 area 0. Soon OSPF neighborship will come up. Done. See the log message. So IP OSPF neighbor, right? And the timer is running. So to avoid it, what I told you, interface serial 3/0. What was the command? IP OSPF demand circuit, right? And so IP OSPF neighbor. So IP OSPF neighbor. Now you can see there is no any timer running. Okay, so configuration is same on serial link on fast Ethernet link. Difference is network type over here is by default point to point. So IP OSPF
Point,
interface serial
point to point.
3/0 include network point to point. That's it. Okay, so if I will talk about the remaining topics, we have distribute list. You know, distribute list is used to filter the prefixes and default information originate, default route propagation, we can say. So these are the remaining, these are two remaining topics of OSPF that we need to cover. So if we can sit tomorrow also, then I
The
can cover the
summarization also.
OSPF. Yes, summarization.
Okay.
One more topic. Summarization. So these three topics. So if you will connect tomorrow, if you can connect tomorrow, then we can cover OSPF. We can finish the OSPF, and then from Monday we can start BGP.
Sir, I think Monday better, sir. Maybe next weekend we can have class if everybody's are okay.
Okay, no worry.
Yes, sir. We have to practice this today's class. Much information we have to practice. Next 2 days.
Today we have only covered the network type, no brother.
Yeah, yes, sir.
5 types
Yeah,
of
most of
networks
them
are
in
there. 7
theory.
types of networks are there. Even you need to learn only 5 types of network. OSPF network type. Which date is of routing?
I guess
18.
18. Okay. So I am uploading the video, and make sure you are going to perform all those